Okay, validity in quantitative educational research. So we're shifting modes again to focus in on quantitative with this screencast. And what you're going to read about and learn about with this screencast are the concepts that you would bring to the table to evaluate quantitative educational research. So this is the basis for which you will use to critique the quality of quantitative educational research. All right, let's get started. Validity in research is probably one of the most complex concepts that we're going to cover. And it's part of the reason it's complex is because validity gets used in many different realms and in many different conversations. And so, right off the hop, I'd like to clarify that when we talk about the validity of a research design, that's a bigger issue. And that's the umbrella under which we are talking about validity for this course. But we will also be talking about validity of our measures. And sometimes those two things, ideas get confounded. And of course, in order to have valid research, you need to have employed valid measures. And so you'll see here in this list, construct validity, which is essentially validity of your measures, is a part of the validity in research argument. There are 5 criteria that you're going to use to evaluate the validity of research. So logical validity is really just answering the question, were the methods of the study capable of answering the question and testing the hypothesis the researcher had stated? Does the hypothesis follow logically from the problem statement? Do the methods follow logically and consistently from the hypothesis? And obviously, if those things are happening, then we should see that the findings flow logically from the methods. And again, finally, the conclusions flow logically from the findings. And so there's this path of argument that's being built in the results that are being presented in a research study. So construct validity, I've mentioned already, is measurement validity. And we're going to spend a lot of time on this later in the course, so I'm not going to spend too much time on this. But essentially, are you measuring what you think you're measuring? So statistical conclusion validity is really assessing whether or not we can trust our results as either being random or something that we would expect to see over and over again if our methods were repeated. And so when we are conducting sample-based research, we are in the world of probability and chance. And if we employ sampling techniques and we use statistical analysis in the right way, we should see with a certain level of confidence that the results are replicable and expected to be something more than just chance alone. Internal validity is the idea that the methods that were employed allow you to make causal claims about relationships between variables. And external validity is about how far you can generalize your results. So according to these 5 criteria, you can basically judge the different types of research that we've covered to date. So logical construct, statistical conclusion, and external validity are relevant to all types of quantitative research. Internal validity research is not relevant for single variable or correlational research, and that's because in single variable and correlational research, you are not looking for causation, you're not looking for X causes Y, you're just trying to establish either the characteristics of certain sample or the presence or absence of relationships. So internal validity is primarily relevant to studies that are trying to draw causal conclusions, that X caused Y, the introduction of this treatment led to improvements in outcomes. And so we're just trying to evaluate the design in order to determine whether or not it's effectively eliminated all plausible alternative explanations. And that's exactly what this slide says. So we will look through the methods and we will decide if a study is internally valid, if there's an absence of reasonable alternative explanations. And the way that's established is through control. So do they implement designs that control for all of the additional variables that could be contributing to any change that we see? We also can use our subjective judgment to determine whether or not we have confidence that there's no other plausible hypothesis that could be explaining the results. And so a lot of that will be based on referring to other results in the literature as you discuss your new findings, and so studies can be judged based on that. And it's important to note that even in a randomized controlled trial, it's not often the case that you can control for everything. So despite the fact that we think that randomized controlled trials are the only way to determine causal relationships, they can often have issues of internal validity as well, and I'll cover a couple of them. So in order to understand and control for threats to internal validity, you need to know the conditions that are required in order to establish causality. Number one, in order for something to be causal, there has to be the existence of a statistical relationship. So this comes from doing statistical analysis of your results, comparing means. Let's say you have a group that was randomly assigned to a treatment and randomly assigned to a control. You calculate their performance of the average performance of the treatment group, the average performance of the control group. You compare those averages. Now, because those averages are based off of samples, they have error associated with them. So the average is the best guess, but there's an interval of guesses that are also likely. And so if those intervals, the interval for the treatment group, the confidence interval for the treatment group around the mean, doesn't overlap the confidence interval for the control group, then you can establish statistical significance of the difference between those means. And there's your statistical relationship. And that's essentially an example of the process of establishing statistical relationship. Then you also have to establish the existence of a time sequence. You have to prove that X comes before Y in order for it to be causal. That's a pretty basic one. And then you have to rule out all plausible alternative causes for any observed relationship. So what are some alternative explanations for established relationships that might exist? And these ones that I'm going to go through here may seem familiar and you've read through them, but these are things that could come up even in a randomized controlled trial. So these next few slides cover off a set of threats to internal validity. They're basically the alternative explanations that may exist for an observed relationship that you've established with your research. And one of the most commonly cited one is history. So for each of these, consider a situation where you've got a group of people, you expose them to an experimental treatment, maybe it's an educational intervention. You measure them after having been exposed to the new treatment, the new intervention, and you determine that they've shown successful achievement of the outcome of importance. Well, it could be the case that history was the reason for that as opposed to your treatment. Maybe the students or the people involved in your study experienced external events that explain the improvement you're seeing. Also, it could be that they just naturally got better at whatever it is you measured at the end of your study. Well, someone might say, well, let's do a pre-test and a post-test. So imagine a situation where you measure baseline performance on a variable you're interested in, you introduce a treatment, you measure post-treated effect, and you calculate the difference, and there you have your effect. Well, it could be that just simply being exposed to the test in the first place was enough to prompt improvement on the post-test. And similarly, we still haven't eliminated history or maturation. Students could have, or participants in your study could have gotten better on the outcome variable simply due to history or maturation. There is also the problem of instrumentation. So if we don't see an effect where we expect to see an effect, it could be that the instrument has just lost its ability to detect the difference we're looking for. Then there's something called statistical regression threat. And so this is a problem with measurement. If your measure has error in it, or you've only included people in your study who are performing very well or very poorly on your measure, then naturally they will regress towards the mean. So people who score in an extremely low area of your scale will, regardless of whether they're treated, will likely score better just due to statistical regression on a follow-up. So additional alternative explanations are selection. So you may start with non-equivalent groups. Either you didn't randomly assign or random assignment didn't work. So one of the groups is potentially more capable than the other group, potentially contains older people or younger people than the other group, and therefore those kinds of things could be the reasons you're seeing a relationship. Similarly, attrition can cause you to see things differently than if there wasn't any attrition. So are the people who remain in your study different than the people who leave the study? And if so, if you had been able to follow up with the people who left your study, would your results be different? Selection maturation interaction is this idea that you've created groups, and one of the groups is maturing faster than the other, and it's not because you didn't randomly assign. It just so happens that random assignment maybe failed, or you don't have the ability to randomly assign, which is often the case in educational research, and therefore one group is somehow benefiting from a more rapid rate of maturation than the other. And that's the same idea with history. So you've randomly assigned, yet one group gets exposed to something that the other group doesn't. So it's the idea of treatment fidelity. Did the people in your study only get exposed to the treatment? Especially in educational research, we often see, if we've created two groups, have one group exposed to an educational intervention, there's nothing to say that they weren't also exposed to other things that could be explaining their improvement. And in fact, it could be that the same thing happens to a control group, where the control group shows improvements despite not having received an intervention, but it's because they've received other kinds of external experiences that helped improve their performance. There are two main factors that reduce the likelihood of finding a relationship. One is that the treatment is not sufficiently long or intense. Treatments need to be designed in a way, and it's especially in education, that they have the impact that they're supposed to have. And so you can increase the likelihood of seeing a relationship by ensuring that your treatment is strong enough. Then you've got this idea of treatment fidelity. And there's lots of different versions of this, but essentially this is whether or not you can be sure that your control group has only experienced the control condition and your treatment group has only experienced the treatment condition. And so there's one famous example called the John Henry effect, or the compensatory rivalry effect. And this is a situation where John Henry was put up against some kind of new machine that was supposed to be able to lay railroad tracks faster than any man. And because he knew that he was the control group, he worked harder and faster than he'd ever worked before in order to show that he isn't as bad as everyone thinks, or that men aren't as bad as everyone thinks. And so his performance was not indicative of the true control group that we were trying to establish. And so the comparison was false. Then there's the idea of the Hawthorne effect, where once you know you're being studied, you end up behaving differently, or trying to do better than you actually would if you weren't being observed or weren't being studied. And so how can you generalize your results if you know that people are behaving differently when they're studied versus when they're not? And then treatment diffusion, this is the idea where the control group finds out what the other group is being exposed to, and essentially exposes themselves to the same treatment. And all of this is about the fidelity of the treatment and control conditions. And so what are some methods for controlling for non-equivalence? So the selection threat. Well, you can eliminate the variable. So you can sample in a way that you only are dealing with potentially young people, if you think that the results would be different depending on the sample's age. You could sample only males, only females, only graduate students, only undergraduate students. If you think that level of education or years of experience change what the relationship you'll be able to see, then eliminate it as a variable and only focus on the people who you expect to see the relationship for. That's not a very good strategy, because it's very interesting when effects change depending on these variables. So you can also just build it into your design, and that's where you introduce it as a moderator. You can use random assignment. Of course, random assignment is the ultimate. That will essentially mitigate any non-equivalence issues if it works. And so what do? You randomly assign, and then you check on a bunch of variables to see that there's no significant difference in those groups. So you can do random assignment, and if you're dealing with a small sample size, you should also follow up and check to see that it worked. And so random assignment doesn't always work because it is random. Sometimes you will end up with one group that's overly intelligent, or overly stressed, or overly motivated, or overly this. And in order for you to be sure, you can do some follow-up. If you're dealing with larger numbers, then random assignment will work. That's the essential beauty of random assignment, is that as long as you aren't putting people into groups based on anything but random chance, then all the other variables involved will be equivalent. So one way, rather than post hoc checking to see if random assignment works, is you select a series of important variables. You match people on those variables. So find two people who are the same age, have the same IQ scores, have the same motivation scores, have the same aptitude scores, whatever it is, and then randomly assign those two individuals to your two conditions or your three conditions or whatever it is. So this is the idea that you're just adding a little bit more control over the randomization process. You're ensuring, especially if you have a small starting sample, that the groups that you create are non-equivalent. So you can use subjects as their own control. So this is essentially just using subjects as a baseline, measuring them prior to being exposed and then measuring them follow-up. You can do some kind of post-statistical control, or something that's called analysis of covariance. This is where you employ statistical techniques to control for the variation that you can attribute to other variables. Or you can do matching without random assignment. This is the case where you don't necessarily have the ability to randomly assign, but you can maybe create groups based on some matching. So what are some of the other methods for controlling for the other threats to internal validity? So we talked about selection bias or selection threat in the last slide. Now we're going to talk about some of those other things like history, maturation. Well, the most powerful way to control for a lot of those things is to employ a control group or a comparison group. And the idea here being that if you have a control group, then you can say that any difference that they experience or improvement that they experience has to be from history, maturation, testing, regression, whatever it is. Any improvement they show has to be due to all these other things that doesn't involve the manipulation, the treatment. And then you look at the difference for the experimental group. And if that difference is even more than what you see for the control group, then that's where you can start to say that there's an effect over and above history, maturation, testing, and regression. So control groups are really powerful ways to eliminate concerns about those issues. So then there's the idea of the control group knowing that they're being treated differently than the experimental group. Well, in order to overcome that, and the problem with that is that they ultimately act differently, knowing that they're not getting the treatment. In order to overcome them, you give them some alternate form of the treatment that's highly unlikely to be affecting the variable you're interested in. And by doing that, you get rid of the issue of compensatory, rivalry or demoralization. The fact that they know that they're not special enough to be treated might affect their performance. And so you want to overcome those things by essentially not letting them know that they aren't being treated. And so this is where the idea of the placebo comes in, and the idea of blinding your respondents or your participants to whether or not they're being treated or whether or not they're part of the control group. It's an important step to override any expectancy effects. And even more powerful would be to employ this double blind, where the experimenter, the people implementing the procedures, don't even know whether or not the participants are getting the treatment versus the control. And so one of the takeaways from this slide is that in order to do a randomized control trial well, you need to implement a lot of control, a lot of design features that essentially might not be possible in the messy world of an educational context. So you know about all of these things. You can start to critically evaluate educational literature based on all of these issues, and then make suggestions for better designs, or make suggestions for how we need to adjust our interpretations of certain results because some of these threats may be present. So moving on to external validity, the main question here is just basically, how far can we generalize our results? Can we generalize back to the population of interest, the target population? And if we can't, who can we generalize to? Is the social setting that we happen to conduct the study in maybe going to change the results that we see? And what about if we use different measures than the ones we actually implemented? Would that change the results we find? So external validity is about the characteristics of the study that might not generalize. And so we start with the population, then we start thinking about context within which the study is conducted, and we start thinking about the different versions of measures that can be used. So there are 5 types of external validity. Population validity is the most common type of external validity, and this refers to whether or not you can generalize from your sample to the target population. It involves, in order to achieve population validity, you have to be very clear on who your target population is, and you have to try to implement some kind of random sampling technique. If it's not possible to do that, then you're going to randomly sample from whatever population is accessible and then generalize to the population that looks like your sample. The next one is ecological validity. Is this idea of, can you generalize from the experimental settings to the authentic real life environment of messy educational world? And so does the amount of control we implemented actually limit the amount of generalizability we can do to real world settings? Temporal validity is this idea of findings might not hold up over time. So results that we see in the 50s might not hold up to the results that we see in the 2000s. And then you have treatment variation. So treatments are often very carefully designed, meticulously designed, because you're trying to. So then there's treatment variation. And this is an interesting one because we design our treatments with the intent of them having the effect we expect to see. And so any slight variation in the treatment might make it so that the treatment doesn't have the effect we expect. So outcome validity. Can we generalize the results to a different but related dependent variable? So dependent variables are the things that are affected, the things that we're trying to show are affected by our treatments. And we want to know, can we generalize the results we saw for this main dependent variable to something that's very similar? An example might be, will a job training program have the same effects on maintaining a job as it does on getting a job? Maintaining a job is slightly different than getting a job. And if we think our results will generalize to that related variable, then we have a high level of external validity. So that covers off the concepts related to internal and external validity that I wanted to discuss. Now, before we close off, I just want to finish by talking about the relationships or the trade-offs between internal and external validity. So as you achieve higher levels of internal validity, you're often doing that at the expense of having high external validity. So the more control you implement, the less likely your results will generalize to a more authentic real-world setting. So it's this idea that you've got certainty when you are achieving high levels of internal validity versus relevance when you're achieving high levels of external validity. And so obviously we want to have high levels of both, but it may not be the case that one study will achieve that result. Okay, so that covers off the topics for the day. We've covered data collection techniques or data collection tools. We've covered sampling and we've covered validity. And validity is a big, big topic. And it's the area that you will be using in order to improve your skills at critiquing articles. You're going to be looking for evidence that the threats to both internal and external validity have been controlled for.